Hi everyone, welcome back to the video about the build of my DIY A320 Neo home cockpit. Okay, this is a part one, which is covering the overall design, overview of the design actually on the cockpit. Okay, so it's going to be a quicker video, but I'm going to go through a lot of overall design concept. Okay, so just to touch base a bit on the design, basically the key structures of the cockpit. So it's going to be a half cockpit. It's actually because of the space limitations, but I'm creating the cockpit. Actually, if you can see here, there is a section where I can build the opposite side, or the first officer side, by just rebuilding the captain side in mirror. Okay, so I plan to do that for the expansion, but for this build I'm gonna start with the half cockpit. So this is actually the decision actually in almost like in the middle, of the build, because then I have to rebuild the room, open up the space. That's a lot of work. So I think, well, I want to make it faster, and I want to start playing rather than to renovate the room or the area where I'm gonna put this cockpit. So I decided just to build half cockpit. Okay, um, and I think it's uh, yeah, kind of compromise, but still gonna be able to enjoy it. So it's going to be semi open. It's not going to be fully closed cockpit because of the time constraint on the space constraint. Also, I cannot build the cockpit shell to kind of put all around covers. But it should be good enough to feel that I was inside the cockpit. So it's going to be the front area. It's going to be okay, and also the side area, there will be going to be a window at least. And then actually I plan to build a second window behind on the uh, rear left side, but I dropped it at the middle of the process. The roof, actually I just built some with some PVC, how do you call it, PVC panels, so it's very light, and they just kind of tape it into the overhead over here. So I'm gonna show you later on. It's just very simple cover here, but yeah, the right side actually is quite open because it's going to be TV over here, showing the right side of the cockpit or the right side of the aircraft if you are putting yourself in front of the aircraft to give a wider field of view. um, yeah, so that's the semi-open, not fully closed decision. Main structure frame is going to be a black steel metal tube, so it's square tube. It's going to be welded black metal. Is black metal steel, black steel, actually black steel metal tube. Going to be welded. I think it's 1/4 inch or 1.5 inch kind of size for this metal tube, mainly for the larger structure. The smaller one would probably 3/4 inch metal tube, a square metal tube. So yeah, so it's basically welding together all the frame, especially to hang these overhead panels. And of course, for the pedestal, it's going to be using MDF, or main density fiber boards. So it's going to be quite sturdy, as long as you don't expose it into the weather or to the water elements. The plywood is probably for the floor base and several structural area that require a bit more. I'm using like I think 3/4 inch thickness plywood. You know what I'm thinking? So it's 1.8 centimeters plywood thickness for certain structures, and the rest is actually quite thin, or like 9 millimeters, or half inch, or uh, kind of plywood. The finish will be painted for the panels, mostly with using a blue gray RAL 7031 coat. I'm actually custom mix the paint to to be able to as much as possible to be close to the real color, because I cannot find the paint that I want to, the type of paint that I'm using for car paint kind of type. Yeah, so it's going to be difficult to find that kind of colors available in market in my country. So I'm just custom mix the colors. The soft finish will be like using fox leather, blue gray. I'm buying actually several sample to until I finally find a match, almost a match on the fox leather, because mostly it's light gray, dark gray, black. There's no blue gray actually, so it's very difficult to find the color of the fox leather that I'm going to be used to cover several of the soft area of the cockpit. On the floor itself, I'm going to be using plywood, as I mentioned. So it's almost a 1.8 centimeters plywood, and then covered with carpet. Initially, I'm using plan to use the tile carpet, but cannot find the right colors, the right texture of the carpet. So finally, I found a roll carpet, roll type carpets, and mostly the right blue that I want to, according to the picture. So that's flooring. And then on the key panel design, I'm going to use again acrylics as the main panels for all the instrument panels and whatever panels inside the cockpit. So it's basically a 3-layer panel. So the top one is going to be 2mm opaque white for the panels, the painted panels and engraved lettering, and below that there's a 2mm clear acrylics. So yeah, so the lights will going to be diffused from the LED strip. Then I'm going to attach in several locations, and the bottom part will be 3mm clear acrylic, just to put to give a strength into the panel. So it's total actually is quite thick, like 7mm panel thickness on each of the panels mostly. And it's going to be laser cut using a laser cut machine for acrylics, and also for engraving the panel to create a lettering or symbols, whatever in the panels. So I'm using I'm going to show you probably the later on in the process on how to cut the acrylics. But this is the basic tools that you're going to need to build most of the cockpit. And then of course the 3D printing for some controllers, knobs, fixtures, and everything. So I'm using both resin and FDM 3D printer. For resin, I'm using I forgot the name, but for FDM, I'm using Prusa 3D Mark 3, if not mistaken. Yeah, so that's the resin 3D printing. I think yeah, you can use any 3D printing, resin 3D printing. I think so. The recent models very good design, actually very high resolution. Mine is the older one, so it's not so good in resolution, but for this purposes it's quite fine. For the applications on the design cell, I'm using two main software, which is the CorelDRAW for designing the panels. So I'm drawing the panels, the switches, the markings, the lettering, and also to cut the hole using the laser cut. So using the CorelDRAW, I'm using version 16. It's quite sufficient, but I have to downgrade to version 12 to be able to use with my 3D print, to be used with my acrylic cutting, because the acrylic cutting machine is only able to accept CorelDRAW 12 version on the file, but that's probably sufficient. So once I created the CorelDRAW design in CorelDRAW 16, I have to downgrade the version to CorelDRAW 12. And then for 3D modeling, I'm mostly using SketchUp to design knobs, or even to lay out, as you can see later on the next video. I'm using Google SketchUp. I'm quite sufficient with that. I have sufficient skill to do that in the SketchUp. And then for PCB schematic, I'm using EC EDA, or EC Electronic Design application for schematic and PCB. So that is for the design itself. Mostly, as I mentioned, for the electronics, I'm going to use the MobiFlight firmware and software this time. I'm not going to use Joy 2 controller, so it's very basic, and then you have to combine another application like Spadnext. While MobiFlight gonna give you what do you call it, customized cockpit design. Let's say for A320, they have the LVAR built into the system, so you can really customize the controller connecting to the MSFS. And the good thing is free, but I donate some money to MobiFlight, so because it's a very excellent, fantastic program to build the cockpit compared to if you buy a very expensive software and application, of course. So thank you for MobiFlight. This is enable me to make my dream come true. With MobiFlight, I'm using the Arduino Mega 2560 because I think it's the largest Arduino with a lot of pins, and I maximize the design using my own DIY shift register circuits, so I can push like I forgot, 3 board of shift register. I forgot. Yeah, it's almost like 36. Yeah, no, 16, 32, almost 48 bits, if I'm mistaken. I have to count again. But I can use 3 board with each of the. No, not 3 boards. I forgot. Yes, only 2 boards of the drive. I have to. I've quite already forget about the design. Sorry, but I'm gonna take a look in the design later on how to maximize the Arduino Mega 2560 with MobiFlight with shift registers for input and output, and I'm using several LED drivers and servo drivers, 7 segment modules for the display, and a lot of another circuits. Okay, so I'm gonna talk about that in details later on. DIY core switch, of course, this is one of the most important one in A320. A320 cockpit use a lot of the core switch. Then you have to create a lot of them. Yeah, so this is one of the main kind of hurdle points on the designs. Once you pass core switch, I think you're fine with the other design. And also a lot of modded off-the-shelf switches, so you create kind of imitating the real switch of the A320 cockpit by using the off-the-shelf switches. Okay, and then of course the PCB and EC ADA kind of design the whole PCB, like for radio panel, audio panel, eCam buttons, and some other design again required if you want to, but you can try to buy several other from the available IO modules in the markets, and that's fine also. But for me, just because I can try to design myself, I try to design a specific PCB for each of the panels. Okay, now just to quickly touch base on the build process, I'm gonna show you the flow that I created. I mentioned I'm not step by step logically created the cockpit, but just to give you how I built it. Okay, so the first step is really about trying to design the cockpit that I'm trying to build in 3D first, because I would like to know the measurement, the angle of the slant angle of the overhead panels, the slant angle of the MIP panels, of the FCU panels, and the size of the center console, pedestal, left console. Without that measurement, I can just it's just a guesstimate, so it's going to be way off the original design, right? So the first step that I'm doing is actually try to recreate the whole models inside the SketchUp, and try to measure and try to scale as accurate as possible. Okay, so to do that, I do a lot of research for reference. There's from photos. I think there's a website in that website that have a lot of real cockpit photo with a measuring tape. So I'm using that website photos as my main reference. And also I bought a 3D model of the cockpit actually in the internet, so I cannot share it to you because there's a copyright for that design. But you can buy it, the 3D models of the cockpit from the market. So you have to pay for it, but it's not that much. So that is using Blender. I open it and then try to remeasure several measurement that is missing from the photos. So I'm using 3D models. Of course, you can go to inside MSFS 2020 if you bought Phoenix, or you have already fly-by-wire, or even the original A320 cockpit from MS 2020. You can just take a look the angle from from any angle that you want to see, right? So you can have a visual kind of cues how it looks in the cockpit. Okay, so you can go inside the Microsoft itself or the simulator itself and try to look around, try to understand how it looks, the feature of the design. Very easy. So without going to the real cockpit, you can already able to do that in MSFS 2020 simulation. So I'm going to Phoenix A320 NX. I take a lot of screen cap for certain angle just to find out how the designs works in the real cockpit. Okay, so yeah, you can do some sim exploration to get the real kind of to not the real one, but trying to simulate the view that you want to see inside the cockpit. Okay, of course, cockpit dimension, as I mentioned, I collect a lot of dimension and trying to transfer it into SketchUp, including the panel size. I try to to measure it accurately and then put it into the SketchUp. Panel reference, of course, you have actually I bought a poster, a digital poster, high resolution poster, and I superimposed that poster behind Corel Draw before I draw the panel. So I redraw the whole panel one by one using that poster as the reference. So I scale the poster into a real measurement of the panels, and then on top of the picture of the poster, I redraw every panel of it into a 3-layer or 4-layer design of the panel. So it's very demanding task. It took me a month to complete the whole redraw of the panels from overhead, MIP, pedestal, and other consoles that I would like to create the panels. Okay, and of course, then you have to plan the electronics and how many. Today I create a Excel sheet to list down every buttons and times the number of bits or the information. Like a 3-position switch will at least have 3 bits information, right? So I put that information into the Excel sheet and then try to count how many pins of logic input or register inputs that I need to have to be able to program that switch, right? To give the input or read the input, the feedback of the switch, and also times the number of LED that you have to light up, right? So the outputs, you have to prepare also how many outputs, digital output that you have to have, and to be able to drive the lights inside the Cori switch. For example, one Cori switch at least have 2 or 1, and depending on the type of Cori switch, then you have to sum it up how many output bits that you have to be able to drive the whole lights inside the cockpit. So those lists I create first and then try to prepare the electronics, number of register, number of Arduino 2560 that I have to have at least to be able to read all the inputs and able to output the LED that to be light up. Okay, and also plus the other requirements, so like servos, driving servos, reading analog inputs from the potentiometer in several area. Later I'm going to show you. Let's say for flaps or trims, I'm using analog input. Okay, so that is the overall design step. Once you get the measurement, then you move on into the next step. The first step is not actually building the structure. So rather than building a frame first, Actually, I start by building the overhead first. So the first panels that I created is the overhead. As I mentioned, the first hurdle point in the design is actually Cori switch, right? Cori switch design is quite to me, because at least if not mistaken, I have to build around 120 Cori switch, if not mistaken, the number of Cori switch required in the whole cockpit. So it's a lot of switch, right? There's a fixed one, there's only light up one, and also the one that is the momentary push, and the one that latch Cori switch. So it's two type, different different purposes, but the same size based on my measurement. So to be able to come up with a very good, reliable Cori switch, I have done a lot of research. I'm going to show you later on when I try to build it. And once I be able to do that, then I start to and then I start the panel design. So I start with the Cori switch, research first, finalize the Cori switch build until I satisfied the build. Once I'm satisfied with that Cori switch, then I start to design the panels using Corel Draw. So I'm starting the overhead panel design from the light panels up to the fire emergency panels and the two sides of the panels, whatever. So that is the flow that I'm taking because of that reason. And then of course after that I'm putting cabling inside and then connected in the mobile flight for testing and programming. That's once you finish the overhead. And then once the overhead done, then I start to build the structures. The structures, I built the structure from the TV frame, metal frame of the cockpit itself, the flooring, main instrument panel, console, center pedestal, left console, and other things. So the structure is actually built next after the overhead. But after that, I'm building the MIP, the FCU. It's much easier because it's a simpler models. And also for the FCU, I didn't really DIY. I bought it actually from Java Simulation, the FCU modules, because to me it's quite complicated for the push-pull buttons to create your own. There's a lot of DIY video and also DIY models actually if you want to build your own. But I thought, well, I want to have a quality FCU because FCU is the most used panels I think during the flight, like altitude, heading, and then also speed and other things. So FCU and EVIS is going to be used a lot. So I thought, well, I bought that something that's already available. So Java Simulation FCU is actually more DIY rather than kind of fabricated or professional manufacturing, but it's a better DIY. Okay, so it's ready-made. There are some quirks in Java Simulation that you have to know, but I'm gonna talk a bit about it later on. Okay, after that, I continue with the center pedestal. After the MIP and FCU, I start the center pedestal construction. So center pedestal is going to be almost to the end of the build, but this time also I'm integrating several off-the-shelf and DIY. Mostly the almost all the panel is DIY except for the throttle quadrant. I'm using a throttle from Throttle Tech, but I dismantle the Throttle Tech throttle set, so I'm buying the mini versions, and then I dismantle the whole thing. I just take the throttle itself and then dump the flaps, the trim, and other side panels. So I don't use that. I just the throttle quadrant mechanisms. Also for Mach 2, I bought again from Java Simulation. Initially it's working fine, but then in the process there's some bugs. I don't know why. It is start disconnecting and unable to read. So I got a bit of like pissed off with the situation. I contact with Throttle Tech. I'm gonna tell you later on the story. But at the end of the day, I break up part that at Mach 2 and rebuild again using MobiFlight and Arduino. So initially it's actually the off-the-shelf product from Java Simulation, but later in the build actually it's becoming DIY. But I'm using the buttons, the case itself, so it's already good. So just the electronics, I replace everything and rewire the whole things into Arduino. DIY spoiler, flap, handbrake, a cam panel, radio panel, everything is DIY. Left console, DIY tiller, but the joystick I'm using Wing joystick for A320, so it's very good, very stiff rather than the Trustmaster one. And actually, it's I bought a rubber boot. It's actually OEM like rubber boot, so it's giving you a very original looks of the side stick. And the next step is system integration. Of course, once you complete all the panels, it is the time to rewire everything, connecting all to the Arduino and connecting the USB power supply, light up the whole panels again, relay. There's a lot of things in the system integration. It took me around 2 months just to integrate the whole systems. And also, one of the most demanding tasks is really programming the switches, the LED outputs into MobiFlight. So I started from the overhead and then moved to pedestal and MIP and other panels. So basically, it's programming the MobiFlight itself is quite demanding because there's a lot of variables to link into the hardware, right? And the last one is of course display, TV, the PFD, the ND display, the eCam display, and the main 4K display, triple 4K display in front. Okay, so we're going to talk about that in the system integration or the display. And the last one is actually finishing it. It takes me another 2-3 months again to finish because there's a lot of small details that I'm fixing it. There's some broken item also because it's DIY. It happens to be like, a lot of cable mess up inside the panels and it's broken. So I need to bug fixing, repaint again some chip paints that during the installation that being dent or whatever, you have to fix it again. And yeah, so there's a lot of work in finishing until I stabilize the product and you'll be able to use it. Okay, so that is the part 1 on the build overall design and on the build process. So we're gonna take a look. There's an links up there and down below in the descriptions to the next part 2, which is we're going to talk about the structures build. Okay, so I'm going to talk about the structure using SketchUp so you can understand how I built the structure of this cockpit. So it's simple, but probably some ideas you can get into your build. Okay, so see you in the part 2 of the video.